Thank you. Before we get started, just take a quick moment to thank our sponsors. Without them, this event would not be possible, so be sure to stop by and say hello throughout the day. Welcome to Clean Architecture with ASP.NET Core 2.1. I'm Jason Taylor and I'm an SSW Solution Architect. You can find me on Twitter at JasonGTAU, on my blog codingflow.net, or on GitHub/JasonGT. I've been developing for 17 years now, and I've said it before and I'll say it again, that the principle KISS, or keep it simple stupid, is the most important principle in software development. I follow that principle every day, and today what I'm hoping to show you is that clean architecture is the simplest approach. You can use it in all cases. It makes it simple to build and maintain all the way from development to production. So let's get started. With clean architecture, we have the domain and the business logic at the center. You can see that the domain layer would contain the enterprise logic and types, and the application layer contains the application logic and types. The difference is the enterprise logic could be shared across other applications, whereas the application logic's typically only going to be used with this application. Now, we don't want the business logic to be dependent on concerns such as infrastructure and persistence, so we invert those dependencies. So infrastructure, persistence, and presentation all take a dependency on that center area. So I wanted to mention that center area, the application layer, and the domain layer is what we refer to as the core. So the outer layer takes a dependency on the core, but the core does not have a dependency on anything. Now, the way that we do that is we add our abstractions and interfaces inside the core, and then infrastructure and persistence implement those abstractions. So say, for example, in persistence, if we were creating a repository, there would be an iRepository in the core, and in persistence, we would implement that iRepository. So it's completely external. And what that results in is an architecture and design that's independent of frameworks. We're not dependent on any specific framework. It's highly testable. We can actually test the core without a UI, without a database, without a web server, and completely unit test it. It's independent of the UI. We can easily swap out, say, the web UI for a console UI. And that's a pretty good place to be in today's day and age because front-end technologies move crazy fast. And if we want to keep up, we need to be flexible. It's independent of the database. Yeah, we might start out with SQL Server or Oracle, but pretty soon we're all going to be moving to Cosmos DB anyway. It's independent of any external agency, so the core actually doesn't know anything at all about the outside world. Before we move on, any questions? No problem. So I want to show you a sample. My sample is Northwind Traders. I know what you're thinking, this guy is crazy. Northwind Traders is so 1992. But I upgraded it. Now it's cross-platform. You can run it on Windows, Mac, and Linux. Tiago just got a MacBook. So yeah, you can run it if you want to. .NET Core, EF Core, Code First, and data seeding. So yeah, Northwind Traders is awesome again. Let's take a look. Okay, so this is the sample solution. I'll zoom in a little bit for you guys. You can see, and I'm going to share a link at the end for the code in the slides. That's right there in this solution, so you can go to my GitHub and grab it. So in this solution, I've got a README, and it describes everything about the project. We won't dive into there yet, but for each layer, you'll find that same README. So if we go to, let's start with domain, contract that a little bit. There's a README for that. So that describes exactly what's supposed to be in this layer, and you can use that as guidance. Same thing with application. So there's a README in every single area. But let's have a look. So you can see the different layers. We've got the domain layer, the application layer, and then the externals, the persistence, the infrastructure, and the web UI, all there illustrated. We've got a common layer, which is just a place for our cross-cutting concerns. The only thing it contains is an datetime interface, so that we've got a nice little abstraction on that. So we're going to look at that throughout the rest of the presentation. What I'm going to do is highlight some of the things that I think are really exciting about this solution, this clean architecture approach. But there's a lot more in there, so be sure to explore it for yourself and find out some of those great things. I mentioned to David just before I started, I've done this presentation in about 3 hours, so I'm going to talk really fast, try and get it done. If you have a question, I'd really appreciate it if you could talk as fast as you can, and we'll get through it together. All right, back to the slide. Okay, so key points of the architecture and design is the domain contains your enterprise-wide logic and types. So that's the logic that you can reuse across the enterprise. If you don't have an enterprise, you're just building a single application, there's probably not going to be too much, but we'll have a look at what it contains. The application contains your application-specific types and logic, and that's typically not going to be shared with other applications. Infrastructure, including persistence, has all of your external concerns. Presentation and infrastructure depend only on application, and they shouldn't depend on each other. So it's good to make this point. You don't want presentation to be dependent on core and also to be dependent on infrastructure. Core is where you should orchestrate all of your logic. If presentation is dependent on core and infrastructure, that forces you to create logic within the presentation layer, logic which is now much harder to test, much harder to reuse. You don't want to do that. So infrastructure and presentation components can be replaced with minimal effort. When you do change those things over, you're just changing the implementation. You're not changing the interfaces or the abstractions that are inside core, and that means that you're not really going to affect any of the logic inside core. It's going to be much easier to do. So let's have a look at the domain layer. So the domain layer sits at the center, and what does it contain? Entities, value objects. We'll have a look at some value objects, enumerations, logic, and exceptions, so custom domain exceptions. So I want to dive in a little bit there. Okay, so domain. So I've got key points that I want to share with you guys. And these are recommendations. These are things that everyone can follow. So the first one is, I don't want to see a lot of data annotations in the projects that I create. So you won't see too many data annotations. We can have a look at an example of what it looks like with data annotations and what it looks like without. So remove data annotations. So here we go. So this is what it looks like with data annotations. We've got a lot of extra kind of attribute soup, just messing up what is the entity. And so my recommendation is don't use data annotations. When we talk about the persistence layer, I'm going to show you the alternate approach, which is, yes?
Can you speak into your microphone, please?
I can try and adjust it a little bit, and I will talk louder. Okay, so yeah, the recommendation is to not use data annotations. All right, next one I want to talk about is to use value objects where appropriate. So value objects are an actual specific type, and I'm talking about value objects as opposed to primitive types. So a lot of the time when we're building our entities, we might have something like a postcode or an AD account, and we think, okay, I'm going to store the postcode as an int, and I'm going to store the AD account as a string. Well, that's really the wrong approach, because a postcode isn't a number. It's a number with specialized rules and logic that govern its use. Same thing with an AD account. An AD account's not a string. It's made up of a domain name. It's made up of a username. It has specific display properties that we need to take into account. And if we store those objects as simple types, then that means everywhere we use them, we have to keep those rules in mind. And we have to write logic to enforce those rules. And if we're not doing it in one place, that means that we're going to be doing it throughout our application. And so a value object allows us to encapsulate that. So I've got a nice AD account value object. And you can see I have a constructor here, which basically takes in a string, breaks it into a domain and a name, throws a nice custom domain exception if it's invalid. Otherwise, everything's happy. Now, this is an example of a custom domain exception, and this is a really important example to make. I could have let it throw, an index out of range because it couldn't interpret the string, but that's going to be a lot harder to debug than AD account invalid exception. Okay? So you can see here I've got some properties for the domain and the name, and I've got a bunch of methods that make working with an AD account value object very easy. So yeah, my point there is prefer value objects over primitive types where it makes sense. That's going to save you a lot of time. It's also going to make it easier for new developers to work with that object. They don't have to think about the logic. They don't have to think about the type. It's all enforced in the entity. All right. Any questions about that? No problem. So the next one that I'd like to recommend in your entities is to always set your collections as private so that they can't be actually initialized by someone else, and to initialize them in the constructor or with the property injection. And the reason for that is you don't have to think anymore. It's done. You don't have to think, has this collection been initialized? Because it has. It's been initialized when you newed up the entity, or it's been initialized by Entity Framework when it returned the result set back. Okay, and that makes it easy for new developers as well. We're talking about putting these conventions in place to force developers into the pit of success. We're making it easy for them to do the right thing and hard for them to do the wrong thing. And that's just great for everyone. All right. So we talked about custom domain exceptions. So that's the main points that I wanted to make about the domain layer. As I said, there's a lot in here. Definitely go and check out the README for each of those layers and you'll learn a lot more. So key points, let me get rid of that. Use data annotations sparingly. We'll look at fluent API configuration later on. Use value objects where appropriate. Definitely think when you're using a primitive type, is this the right approach? You save yourself a lot of effort. Initialize all collections and use private setter. Entity Framework Core is really good at working with that type of thing now, so you don't have any worries. And create custom domain exceptions. Okay, let's move on and look at the application layer. This is the most exciting part of my presentation. And there's 3 sections after that, so apologies. However, the reason for that is because this is the outermost layer of the core. This is where all of our business logic happens, and this is where we have to work really hard to make sure that the core is going to be there in 20 years' time. We're building enterprise applications, and this is where it all happens. Everything else outside of the core is an afterthought. It's exchangeable. You know, Angular 6 is not going to be important in 5 years' time. It's going to be Vue probably. So this is it. This is where it all happens. All right, it could be Aurelia. Those guys are really noisy. Yeah, there you go. There, see? All right, so the application layer contains interfaces, models, logic, commands and queries. We're going to talk a little bit about those. Validators and exceptions. So I want to start by talking about CQRS. Now I think Tiago knows what that means. Nice, yeah, so it's command query responsibility segregation. So it separates reads, your queries, from writes, your commands. And a lot of people will talk about, yeah, it can maximize performance, scalability, and security. I don't care about any of that. What it maximizes for me is simplicity. When I separate those two things together, I have this tiny little object that encapsulates one thing, either a read or a write, and that's fantastic. So it can simplify your overall design. It's easy to add new features because we're just adding a new query or a command, or maybe a few of those things. And it's easy to maintain. If you have to make a change, you're not likely to break too much, hopefully. We're only changing one command or query, and we've got tests that are making sure that everything's okay. So that's CQRS. Now I want to talk about Mediator. Mediator is a library built by Jimmy Bogard, and it's about messaging. And you add that to CQRS and that equals love. It's the perfect combination. Now, I would have started using Mediator about a year ago when my friend Brendan Richards told me about it, but I had my blinkers on. I said to him, no, this violates the explicit dependencies principle. And he said, yeah, I can see what you're saying there. But the explicit dependencies principle states that all dependencies should be explicit. So, you know, you put them in constructor. When you use Mediator, what you're going to see is that actually there's just one dependency, there's Mediator. And so I said, no, I'm not going to use Mediator. So sorry, Brandon. But then I heard about it from Steve Smith. And Steve Smith is a really cool guy. And I'm like, awesome. I'm going to start using Mediator now. So let's have a look. With Mediator, we define our commands and queries as requests. So everything is a request. Our application layer then is just a series of request response objects. And with that, we get the ability to attach additional behavior before and or after each request. So cross-cutting concerns like logging, caching, authorization in our application layer, we have one place in which we can do that. And I'm going to show you that now. And this is some of my favorite stuff. I really like Mediator. Sorry, Brendan. All right. So the application layer has, let's see, this infrastructure. And you can see in here, I'm just going to bring up my little key points because I hate to miss anything for you guys. Okay. So we'll start with logging. So with Mediator, I can attach additional behavior to my requests. And I want to show you this. This is how, let me make it even bigger. This is the code that's required for me to log every single request, every single query or command that passes through the application layer. And let me be clear, everything that comes through the application layer is either a query or command. So I have 100% logging on all of my queries and commands, and it logs the name of the request and the actual DTO, the information that was sent to make the request. So if we were making a request to get a customer by ID, then it's going to say, hey, this is an authoring request. The name was get customer by ID, and the ID that we requested was JSON. And that information is going to be available, ready to use, every single request. Okay. Now, what about performance problems? I've got one for that too. So this one's a little bit different. The request logger actually ran before the request. This one runs before and after. So you can see here, this is simple too. I basically start a timer, system.diagnostics timer. I wait for the response to finish. I stop the timer. And if the time was greater than 500 milliseconds, I say, yeah, no, that's too slow. So we log a warning, same sort of thing. We log the details of the request, and we log the detail of the request itself. I've got a to-do there to add the user details. I did that because I want to highlight, you know, with all of these logs that go in, you should have the user information. So if the user actually calls up and complains, you can say, okay, what time did you make the request? What time did you experience the issue? And you can say, oh yeah, I can see that now. I've got all of these requests. I can see the slow running one, and I'll look into it for you. So that's really simple. And then my favorite one, my favorite cross-cutting concern, and I've just implemented this, is validation. Any request or command that comes in, I'm going to validate that DTO to make sure that it's actually, you know, it's actually worth looking at. So let's have a look at some examples here. I want to find a command that's got some validation. This one's a bit ugly, but no, that's too ugly. Let's look at this one. So this is my update customer command. And actually, I'm going to go on a tangent, and then we're going to come back to validation. Because what I want to show you is that data annotations are ugly, even here for validation. And fluent validation is awesome. So who's heard of fluent validation? Show of hands. So everyone, right? Yeah, so just use fluent validation, because fluent validation can support your simple scenarios such as, hey, our address has a maximum length of 60, and your complicated scenarios such as the phone must have a Queensland landline when the country is Australia and the postcode starts with 4. So we can actually build in complex validation scenarios with fluent validation. We can't do that as easily with data annotations, so keep that in mind. So what I've done for this request, this is an update customer command request, and it includes all of the details to update a customer in persistence. So you can see that it has an associated validator, and I have a nice mediator, where is it? In here, behavior that will validate that request, and it will validate it automatically. So, you know, when we're talking ASP.NET Core, we're thinking, okay, so the request comes in through the controller, we check the model state, ASP.NET Core 2.1 does it automatically, so that's great. So we check it, and if it's bad, it returns a bad request. But that's no good in a clean architecture scenario. It's too late. We want the validation to occur in our core. That's a business rule. They've got very defined steps around that validation. And if we switch out the web UI for a console UI or something, we want that validation to still be there. If it's in the ASP.NET, that's not as useful. So with this behavior, with this mediator behavior, I've moved that into the core without any of those dependencies. So now all of those requests and commands are validated automatically. So we have automatic logging, we have automatic performance logging, and we have automatic validation. And we can expand on that further. We can start to think about caching. Do we want to cache some of those reads? We can think about authorization. Do we want to check this user and make sure that they're authorized to execute this command or query, all using this pipeline in the application, in the core. So it's pretty cool. All right, now I didn't show too much about how these commands and queries are structured, so I'm going to have a really quick look at that with you guys now. So you can see here that I've got a create customer command and command handler. So what mediator does is everything becomes a request. So in the query, I've got a get customer detail query and query handler. So the query or the command is just a DTO, okay? It's the information that we need to send to the application layer to execute that command or query. So this particular DTO just requires an ID, and it will return a customer detail model. So that I request there, you're seeing that's mediator. So mediator will match that up to the handler. I'll make that a bit bigger. So this is a get customer detail handler, and it handles a get customer detail query, and it returns a customer detail model. Okay, so it supports dependency injection. You can see I'm injecting a context there, and over here I'm handling it. So that's it. I have this one place where I encapsulate all of the logic that goes into getting the customer detail. Now if I want to use that elsewhere, that's no problem. And it doesn't matter what client is calling it, it's the same logic. Same steps are applied. All right. Any questions about the commands or queries? Yes?
Why not just use the customer Excel instead of the model? Do you need models as such?
Yeah, it's a good idea. So essentially, if we move those entities outside of the core, then we're creating a dependency kind of between those external concerns and those internal concerns. And the fact of the matter is that the customer doesn't contain all of the details that we need on the view, you know, on the client. So let me see if I can show a quick example of that. Let's have a look at, I think I've got a good example on my product view model. Okay, so yeah, we could send the entity out, but generally on the view, on the client, the web UI, the console UI, we need a bit more information. So when we get the product details, as it is in this case, we want to know, can this user edit this product? Because that's going to affect how we display the interface. We want to know, can the user delete this product? So yeah, generally speaking, not a good idea to send the entities out because they're kind of a lower level concept. Better to send those view models or DTOs out because we can customize them to suit the purposes of the view or whatever interaction it is that we have. Good question. Any other questions? No problem. Okay, hopefully I captured the key points. Let's see. So using CQRS and Mediator simplifies your overall design. Fluent validation is useful for simple and complex validation scenarios. And Mediator simplifies cross-cutting concerns such as logging and validation. So as I said, that's my favorite part. Who thinks that's cool? Yeah. Okay, fantastic. Glad to hear it. It really is a game changer because that core is completely isolated from everything in the external world, and yet it encapsulates completely all of our business logic. So in 20 years' time, yeah, maybe we'll convert it from C# to Java because we can't C# anymore, but it's still going to be the same logic. And you know, that's important for building enterprise apps. So, all right, and it's independent of infrastructure and data access concerns. So we do that via dependency inversion. So let's have a look at the persistence layer. So the persistence layer, as I said, is an external concern, and it contains things like the DB context, migrations, configurations, seeding, and abstractions. So now we've got the big question. Should we implement the unit of work and repository patterns? So hands up, who thinks we should not implement these patterns with Entity Framework Core, especially 2.1? Damn, guys, that's like 10 people. Okay, so hands up if you think we should implement these patterns. Okay, that's like 10. Who's still just using ADO.NET? Okay, no worries. ADO 2.7? I'm pretty old. Okay, so I would say it's not always the best choice because the DB context, in Entity Framework Core, the DB context actually insulates your code from those database changes. So if you want to switch out SQL Server for Oracle, that's okay because DB context is an abstraction. There's not too much to worry about there. DB context is already a unit of work, so it acts like a unit of work. And DB set acts as a repository. So a lot of the time what people will say is we need to implement a unit of work and a repository so that we're abstracted from SQL Server or from Oracle. Well, that's not a good reason when you're working with Entity Framework Core because it already does that for you. So there are good reasons, but that's not a good reason. So the other reason people might say is, well, I can't unit test my stuff. Well, that's not true anymore. With Entity Framework, we have really nice tools for unit testing code that depends directly on the DB context. So I've got another talk on that. You can check it out on tv.ssw.com. But yeah, rest assured that you can unit test it and you're good to go. So what do the experts think? So this is really important. So Jimmy Bogard, he's the creator of AutoMapper, Mediator, and general all-around good guy and DDD expert. He says, I'm over repositories, definitely over abstracting your data layer. So a big no from Jimmy. He's a big fan of CQRS and he thinks that's a much better approach, and I agree. So we've got Steve Smith, and he says, well, no, you don't need a repository, but there are many benefits and you should consider it. Now, while he says you don't need a repository, he's definitely being very diplomatic there. He loves repository. He's got a great approach to creating repositories, and I think we'd put him on, yeah, I'm going to create a repository.
I've been using genetic repos for years.
Yep.
So, I mean, why should I change?
No, you don't need to change. What you need to decide is what works for you. And if what works for you at some point becomes too painful, then change. But if it works, it works.
It's mostly that genetic repo that code's done. So.
Yeah, that's it. And look, if you're using a generic repository, you should definitely check out some of Steve Smith's resources because he has a great approach, and in particular, pay attention to the specification pattern because that'll stop you from having what's known as a leaky abstraction, where some of the Entity Framework stuff actually does end up leaking into your business logic. So yeah, he's a fan of the repositories. And then finally, we've got John Smith. He's about to release a book, Entity Framework Core in Action. Julie Lohman's very excited about it. And he says, no, the repository and unit of work pattern isn't useful with EF Core. So you can see there that we basically have people on both sides of the fence. But I think with architecture and design, it always depends. There are good reasons to implement the unit of work and repository pattern. They just don't come up as often in many applications that you build. One good reason is you might like to use a repository to control access to your entities. So with a DB context, a developer, any developer, junior developer, they can do what they want. So if we're talking about an ordering system such as Northwind, they can go ahead and add, update, or delete orders. They can add, update, or delete order details, that sort of thing. But with a repository, we could create an order repository, and that's on an aggregate root. And we basically stop those developers from having that capability. If they want to update an order detail, they actually have to update an order. And within that encapsulation, we have logic to control the updating of the order details to make sure that everything's working correctly. So yes, repositories and unit of work are still useful, but in the general case, you can get away without using them.
Question.
Yes?
Could it be a use case for a multi-tenancy system?
Possibly. It just depends on your design.
Yeah, so
Yeah. So with architecture and design, it always depends. Multi-tenancy, possibly. Yes. All right, so let's have a look at the persistence layer. Okay, so in this application, of course, I've decided not to implement these patterns. And let's see. And so even though my application logic, my core, is using the DB context directly, I'm still independent of the database. So if I wanted to switch out the database, all I have to do is switch out the provider that I'm using. So currently, I'm using SQL Server, but later on I could switch that out for Postgres by changing this provider. And we've done that, and it's been fine. Okay, the next thing I'd like to point out is to prefer conventions over configuration. And this is coming back to the domain a little bit. When you're working with Entity Framework Core, it's important to know your conventions. It should be one of the first things that you learn. If you know your conventions, you're going to be more productive with the tool. And that extends to all tools that use conventions over configuration. So, for example, AutoMapper and Mediator. So let's have a look at how that works. So if I bring up my customer entity. My customer entity has a customer ID. Now, by convention with Entity Framework Core, when it maps that, it knows that that's a primary key. It could be called ID or customer ID, and it will map it, no problem. So what I shouldn't do then is go ahead and tell it that it's a key. So that I would do that if I really didn't understand the conventions very well. That's configuration. I'm telling Entity Framework Core that that's a key, but the fact of the matter is it already knew it's a key. And as you know, I don't really like data annotations. Yes, question?
How does Entity Framework detect that it's a primary key? Does it use reflection?
It's a convention, yeah. So when it reads the domain model, yeah, it understands that that particular property just meets the requirements and it's a primary key. So the convention is that if the property is called ID or the property is called customer ID, which is in line with the name of the class, then Entity Framework will say, yep, that's a key.
What is if it's going to search for this property, does it make it slower?
No, and really that's a design time consideration rather than a runtime consideration. All of that's already done.
All the applications of that anyway, so I'm assuming the framework does the same thing.
Yeah. All right. Let me see. Okay, so the other one that I wanted you to keep in mind was to prefer configuration, fluent configuration over data annotation. So I talked about that with the customer entity where I had data annotations everywhere. Well, I can just use fluent API configuration in a separate file without actually messing up my entity at all.
Shouldn't that be part of the domain though?
It's part of the ORM. So it's the configuration that teaches the ORM how to map it from a kind of in-memory model to a physical model. And if you try to move all of the data concerns into the domain, and I did try that. I tried that. People get really upset. They really don't, yeah. No, it's not validation, yes. So this is our configuration. Yes? Oh, okay, yes, thank you, yes. I will do. All right, so let me see. So we've got prefer the conventions over configuration, fluent API configuration over data annotations. Oh yes, and this last thing. So with Entity Framework Core 2.1, we don't actually have a nice way to automatically apply all of these configurations that we've created. So I've created in this project a nice little extension method, and you can just run modelbuilder.apply all configurations. And so in the future, when you add a new configuration, you don't need to think and remember, you know, I've got to go and add that line, because you forget. I forget. It's annoying. All right. So key points. Independent of the database, and that's when we use DB context directly. Entity Framework Core, think of it as one big abstraction, switch out the provider, and you're using a different database. You should prefer conventions over configuration for any framework that is conventions over configuration. Use Fluent API configuration over data annotations so that you can keep your entities nice and clean. And use an extension such as the one in Northwind Traders to automatically apply all of those entity type configurations. All right, now we're going to have a look at the infrastructure layer. This is really quick. Basically, the infrastructure layer contains implementations. Implementations for accessing web API clients, file system, email, SMS, system clock, basically anything external. So they're just implementations. The abstractions or interfaces are contained within core. And so when we write our logic in core, we're just writing against the abstractions or interface. There's actually no direct relationship to the implementation except at runtime when we wire it up with dependency injection. And that means that we can switch it out. So if we're using SendGrid, we can switch it out for email. If we're using email, we can switch it out for SMS. And it's not going to change the business logic. It's still going to be able to send a notification. Let's have a look at that. Okay. And if I didn't mention it before, infrastructure and persistence, they're both infrastructure, okay? Just external concerns. So in my infrastructure, I've just got two services to demonstrate. I've got the machine date time and the notification service. And you might be wondering, well, why should we abstract the date time? Well, the reason is that if you don't, it makes it harder to write unit tests. If you have some logic that's only going to run on Wednesdays and you're relying on datetime.now all throughout your code, well, you can only test that on Wednesdays, which is kind of, it's gonna slow you down a bit. All right, and I have this notification service. So you see the notification service doesn't do much, but I just want to show you how it works. So if we go to, let's see, that's that one. I think it's in create customer command. There's our command, there's our handler. Okay, yeah, great. So this is an example of core dealing with external concerns via dependency inversion. So you can see here that we're injecting the DB context and a notification service, but we're only using the iNotification service. And that's really important. Of course, we don't actually have a reference to the infrastructure project, so we couldn't actually new up the real notification service if we wanted to, which is great for junior developers because they're not going to do the wrong thing. We're forcing them into the pit of success again. So you can see here that, yeah, we go and add a customer and that's all good fun, but then we call the notification service and it's just an interface, so we're just saying notification service.send and that's it. And you can see here, that's what this is about. We've got a simple command and it orchestrates the logic, the business logic for creating a customer. There are many different ways that we can do this, but in this example, we've got one nice place in which we can go and write that logic. One nice place that we can come back to when we need to change it. And it's changed everywhere. All right. So infrastructure is pretty simple. Anything external, keep it in infrastructure. Don't let it come into your core. Yes, and I should mention that no layers depend on infrastructure. Okay. Key points. Classes contains classes for accessing external resources such as file systems, web services, everything external, guys. Implements abstractions and interfaces defined within the application layer, and that's how you write your logic. You've got those abstractions. When you unit test, you're just mocking an abstraction. There's no actual integration required. And no layers depend on the infrastructure layer. So presentation shouldn't take a dependency on the infrastructure layer because, as I mentioned before, that just makes it harder to test your code. And finally, the presentation layer. So presentation layer can be whatever you want. It could be a SPA, an Angular or React application. It could be just a web API, as is the case currently with Northwind Traders. It could be a Razor Pages application, MVC, or web forms. In fact, it can be anything, like it can be a console UI, it can be a Windows service. The important thing is that what's in the presentation layer only has a dependency on the application layer, and that's where all the business logic is. So the UI really doesn't matter. We don't need it, except for, users. All right. Let's have a look at the presentation layer. I like to do a little bit of a review of the controllers when I show the presentation layer, because it's a bit of a history for how we used to do things and how we do things now. So I think my product controller best illustrates that. So let's have a look at the history. Where do we go? I've got a note. Yeah. I think right here. Okay. So this is what a typical controller looks like for most new developers. They'll go ahead and inject the context like I'm doing. I'm not injecting it into my controller because that's too low level for something in the UI. And this controller also contains actions that are returning entities. So as we mentioned before, thank you for that question, we should be returning view models or GTOs, something that's better suited to the client, to the presentation. So two problems with this. We're injecting a really low level concept too early, and we're using entities. And the other big problem is we've got nowhere to encapsulate our business logic. Like, sure, you know, it might be a simple application. We can put our business logic for creating a product here or updating a product, which is a little bit more complicated. But we can't reuse that. I mean, maybe we could create a console UI that use up a ASP.NET Core controller, but you should probably just stop there. So we need to make it reusable. So I want to see, where do we go from there? Okay, so here's how I was developing for a little while. I would actually just create these queries and commands. So with CQRS, and yeah, I can't navigate to that anymore, but basically they just have one method, execute. So I could inject these straight into the controller. I could go ahead and you know, get all products, just execute it. It would return a view model or a DTO, so much better. We're avoiding a lot of those problems. The logic's encapsulated, and that was before, you know, when I was still resisting Mediator. And then we started using Mediator. And this is really cool. So you can see I'm only injecting one thing now. I'm just injecting Mediator. And when I want to run a Mediator request, I just say, hey, Mediator, I'm sending you a query, or I'm sending you a command. And it'll go ahead and run that query or command and return the results. So that was really cool. So we went from injecting, like, I don't know, 5 dependencies to injecting 1. And then I was like, no, that's too many. We gotta fix that. So let's see, where did I fix that? Maybe here? Yes. So I implemented a base controller which uses property injection. So we don't need to inject Mediator anymore. We can just use it. So now we just have a controller which is just actions and infrastructure. It has one responsibility, and that's to convert a request into a response. There's no business logic. Nothing happens in here except 1 or 2 lines of code. It's just, we're just passing through, straight through from the presentation layer to the application layer where all the magic's happening. So I was pretty happy with that. I don't think there's too much else going on there. Yeah, very excited. So that's how your controllers should look. You know, we've always known that they should be skinny, but now they actually just do nothing, which is great. So we mentioned before, when we looked at the product view model, we should create and consume well-defined view models. So don't pass back entities, pass back more than that. Think about, what is my client likely to need? Because let's say when you're on the Angular front end and you get back the product and you're displaying it, well, then you need to know, hey, can they edit this? Can they delete this? Well, one way that you could get that information is you could make another request back and you could get their authorization information. But really, you can just send it back on the view model right from the beginning, and then it's just one request, and you don't have to write the logic to figure out whether they should be editing or deleting on the front end, because that's already been done, and it's done in the application layer. So that's done for every presentation UI that you create in the future. Like, that's a done deal. 20 years you can use that, you know, probably. We'll see. All right. Oh yes, and I wanted to show OpenAPI, because OpenAPI is one of my favorite things. So OpenAPI allows us to bridge the gap between the back end and the front end. So yeah, we spend a lot of time creating this web API, but then when we get to our front end, we have to write code to access that web API. Well, with the right tools, you don't actually have to do that. I'm going to run this, open up my favorite tool, NSwag Studio, and what we can actually do is I can show you how I can generate an Angular client or a C# client to access that web API. So this is Northwind Traders. I probably should have shown you before now. It's just a web API. Later on, we're going to add a SPA and Razor Pages and maybe some React. We'll keep working on it. Feel free to contribute. It's open source. I've been getting a few pull requests, which is really nice. It's really very exciting. But let's have a look at NSwag. So NSwag allows me to take this Swagger specification, just like this. I can paste it right in here and go generate outputs. So the Swagger specification is an API document that describes the endpoints and the things that my API can do. So easy. If I want to create a TypeScript client, I can click on TypeScript client, and I'm going to zoom in for you guys real quick. We'll get rid of that. Go to settings, and I can say, okay, I'm going to generate this TypeScript client for TypeScript 2.7, and we're going to use an Angular template. And we need to use, latest and greatest, of course, because that's what hurts the most. Let's see, zoom down a little bit. What do we got? This one. Sorry, that's a little bit hard to see. I'm just going to zoom out so I can get it done for you guys. That's pretty good. One thing I like to do is to actually generate interfaces. So if we hit generate outputs on that, now it's actually going to generate a really cool Angular TypeScript client for us. So if you're building Angular single-page apps and you're writing code to access Web API, you don't have to do that anymore. You can just use a tool like this. It'll generate it for you, and you don't have to worry. Now, the things that I like about this the most is we've got these nice interfaces that explain the methods that are available in our admin client. Let's go to our customers client. That might be more interesting. So here's our customers client. So get all, create, get, update, delete. It's all up front there for us to see. Not only that, those DTOs and view models that we created have been created for Angular also. So in TypeScript, so you don't have to create those. The source of truth is in the web API, and now we've brought that over to the front end without actually writing any code. And when it changes on the back end, we're going to update it again, and we'll get the latest on the front end. So pretty cool. Who here is using Swagger and loving what they see? Yeah, it's awesome. You guys know. That's good. That is it. So key points. Controllers should not contain any application logic. Create and consume well-defined view models. And utilizing open API bridges the gap between the front end and the back end. I just have some resources for you guys. So the first one is building monoliths. Good news is that there's a link at the end, and it contains a link to the slides and the code, and it includes links to all of these resources. So you don't have to take a photo just yet if you want to. So building monoliths, this is what got me excited about clean architecture. This is by Steve Smith. And then microservices. So this is another book from Microsoft's architecture guidance. And don't be put off by the fact that it says microservices, it says containers, and it says Azure. Just read it because it's completely applicable to every application that you build. It's got such good information in there. Good to go. Also look at Clean Architecture by Uncle Bob. I didn't mention Uncle Bob yet, but obviously it's a good resource to mention since he came up with the whole concept. The thing I love about this book is he said he's been developing clean architecture, or he's been developing applications for 50 years, and he feels that the architecture rules are all the same, and the rules that I showed you today are those rules. So no matter what application you're building. And finally, if you like what you saw today, we run a full day training on .NET Core. And this is the content that we covered. I'll talk a little bit slower, and I'll have a few more examples. So if you enjoyed what you saw today, the next steps, grab the code and slides and get started. Create an application for yourself, whether it's for a demo or for the company that you're working on, and try it out. I think that you'll find that it really is simple. You'll have an application that's easy to build and maintain all the way from development to production. Thank you.